All right, so this problem today that we're looking over is actually gave to me by a commenter who was looking to help with basically creating a program that can check and see if there is a prime number in a list, right? So I've already got that function set up, but I'm going to walk through basically just building the program from scratch, really. So as you can see here, I created a new function called find primes. So I'm going to go ahead and make that find primes 2. And the reason I kind of wanted to go through it a little bit more in depth is to show you what I was doing rather than just explain the program I'd already built. So I made that. I don't know what I made that as. I should have made it as an operator. Find primes 2 and click enter. Okay, so the first thing we're going to do is give it an input, which is a variable. So you can see here, I'm just calling it search list. It's a pretty generic name. I had some variables set up, but just to kind of go over the basics, we need to first iterate over all the items in the list, right? This is kind of our basic starting point. So we are going to say we want to iterate from I equals 1 to the length of the list, which will basically flag each one in the list. So length of search list right here. The second thing that we need to do in order to make this is we need to test for the numbers. Basically, a prime number will be divisible by something from either 2 to half of itself, right? So if we have a number 400, we basically want to see if the prime number that we're testing is divisible by any number underneath it, right? So what I'm going to do to make it easy is we're going to start at 2 because every number is divisible, or I should say every integer is divisible by 1. And then we want to go to half the size of the number. So I'm going to go to variables. Actually, no, yeah, this is right. Right here, I'm going to divide our item by half. So pull item out right here, item 1. Now, one thing that we want to make sure we do is we're using the same variable I here for both loops. We want to change I by clicking it. I just type in J and click enter. So this is basically, this is a nested loop. So the first thing we're going to do is iterate through every single number and check them. But in order to check that number, we need to iterate from 2 to half that number, right? So that's basically what we're doing right here. So inside this for loop, we want a if statement. So I'm going to pull an if statement right here. And we want to check and see if our number is divisible by any number beneath it. So again, we use a modulo operator that basically says the remainder of an operation. So I go ahead and click that up there. If item I of search list, go ahead and duplicate that, is divisible by j is equal to 0, then we know that that number is not prime, right? So in order to make sure that we actually do something here, what I'm going to do is set up a flag. Now, a flag is a variable. I'm going to call it NonPrime Flag, where basically the number is either it's flagged or it's not, right? So the number is either going to be set to 1 or we're just going to leave it alone. So here I'll set 1. As you can see, I have a NonPrime Flag right there. So I'm going to change this to NonPrime Flag. We're going to set the NonPrime Flag to 1, which basically says, hey, this thing is not good, right? So that is the basics of it so far, but there are a few more things we want to check, right? I'm going to set NonPrime Flag to 0 when we first begin because we want to make sure we create the variable in a predefined state, right? That way the next time we want it, it's not set to 1 because we ran it with a list earlier. So NonPrime Flag is set to 0, and then another thing I want to do is I also want to set the NonPrime Flag to 0 for each number, right? Because we set it to 0 in the very beginning, but then what happens if a number ends up being non-prime, right? We're going to set the non-prime flag to 1, but then that never changes, right? Each time I iterate through each number in the list, I want to reset prime flag to 0 and then do my checks once more, right? That's going to make it so not prime flag stays consistent. But we're still missing one more piece. Now I'm going to create a list called, let's just call it check flag. So check flag is what I'm going to use because at the very end, I need to see if we've had any prime numbers, right? So what I'm going to do is I'm going to set something in here that sets prime check flag to 1, right? Now, before I continue using it, I'm going to go ahead and set it out here. I want to show why prime flag is or check flag is important. So I have an if else statement right here, and I'm going to do an operator if my check flag is equal to something. So when we're going through this list, right, every single time I go through, if I have a non-prime number, we're going to set the non-prime flag to 1. When we keep going, at the very end, non-prime flag is going to be 1 unless we have a list of completely prime numbers, right? Because it's going to get set to 1 if we have a number that can be divisible by 2 or 3 or so on and so on, right? So what I want to say is, you know what, if this check flag that we're going to use later, which is going to be the final one we want to check, is equal to 1, that's when we're going to say we have a prime number. And if it's not, that's when we're going to say that we don't have a prime number. So I'm going to take this in, go ahead and duplicate these. I'm going to set them to 4 seconds. I think that's a solid amount of time. And I'm going to say this number, this list contains a prime number. And I'm going to do an exclamation mark because we're excited. I'm going to hit Control, All, Copy. I'm going to say this list does not contain a prime number. All right. Contains. If I remember how to type. Okay, I'm going to click OK real quick to save that. That way I don't, get messed up later down the road. I need to find that find primes too. Go ahead and edit it once more. So the last part that we're missing is setting the check flag. So what I'm going to do is do Control and use an if statement right here. Nope, right here. So each time we loop through each number, right, we say we're basically checking all the numbers below that number to see if it's divisible by any of those. And then we're going to say if that number is divisible, if it's not prime, we're going to set the not prime flag to 1. But then later, I want to set another variable right here where I'm checking if that not prime flag has been tripped. So I'm going to say if variables not prime flag equals 0, which means that that number was never divisible by anything. The one we just iterated through, we're going to set the check flag to 1. So again, I'm going to do this real quick because I want check flag to be consistent each time I run the script. So this is our block right here, and I'm going to click apply. So it saves it real quick. And here's what we're looking at, right? In the very beginning, I set both of my flags to 0. I have a for loop that iterates through the entire length of the search list to look through each component of that list. In each one, I set the prime flag to 0 to reset it once more. And then I have a loop that basically loops through every number from 2 to half of the item that we're looking at. So if we're looking at 10, I would go from 2 to 3 to 4 to 5. If the item that we're looking at, so if the number is 10, is divisible by, say we start out with 2, and that is no remainder, we're going to set that non-prime flag to 1, right? So we go through every single number. We drop down here, we say if that not prime flag was never tripped, so if it never got set to 1, right, we are going to set the check flag to 1. And then at the very end, once we're done with both those loops, we come down here to this if-else statement, and it says if the check flag is 1, if that thing was never tripped, we're going to say this list contains a prime number. And then, of course, if it's not, that else statement, this list does not contain a prime number. So I'm going to click OK. One thing I find when I write code on the fly during these videos is sometimes it ends up messed up just because I don't really have time to test it. And I like doing these in one take. So I do have this other one over here just in case this one does not go well. So I'm going to plug numbers in right there. You can see I'm setting numbers to a list that contains 4, 16, 18. None of these numbers are prime, right? So we're going to test it. Theoretically, it should tell me that my list does not contain a prime number. So now if I take it and I set this instead to 7 and let's say 17. So I have 2 prime numbers. We're going to click it. And it's going to say this list does contain a prime number. Now, a few things to keep in mind. This does get kind of, resource intensive, or it just takes a while for the computer to do if you have a large number of lists of items in your list, just because, you're doing 2 for loops. So you're checking everything twice. Not only that, but you, also have to do a little bit of math and everything for it to go ahead and compute. Another option that we could take, I'm not going to show in this video, but would be to simply set up a list of prime numbers and then check and see if any of the numbers in the list hit one of those list of prime numbers. Of course, you can't do every single prime number just because there are so many. So it would be non-scalable. So you wouldn't be able to really, test really high numbers. It just really isn't the smartest idea. Besides that, another thing I would recommend is that, testing maybe a couple of rules instead. So for each number, basically iterating through and setting up an if-then statement that says, hey, if it is divisible by 2, it's not a prime number. Or if it is divisible by 3, 4, if it ends in a particular number, it's not prime. Would certainly be another way that you could test it. But again, it's a little bit more strict that way, so you can't really scale it. You might hit some numbers that kind of betray certain rules, like 49, or not 49. There's just a couple of numbers where you're going to hit them and it doesn't seem like a prime, but it really is. So with that being said, I'm going to do one more thing. I'm going to click edit. I'm going to go ahead and show my code right here. In the description of the video, I'll let you guys know that you can come and see the definition, the final definition right here. But this is basically what we just created. So if you do want to help recreate it, or if you want to see if you kind of misplaced something along the way, please do refer to this screenshot right here. So thank you guys very much. That is the video. I hope it is very helpful. I hope you enjoy it. Please leave me feedback. Thank you guys very much.